In part 2 of this lesson, we have the following three examples. In question number 1, they want us to integrate x times cosine 3x dx. To do all three of these examples, we need to use integration by parts. And to use integration by parts, we'll use the following formula, where if we have, let's say, u dv, and we're integrating that, we can break up u and dv as uv minus the integral of v with respect to du. Now, if that's a lot to take in, let's start with question number 1, and I'll demonstrate what I mean. What we have here is a product of x times cosine 3x. We have to choose an appropriate u and an appropriate dv. The expression that we choose for u is what we will find the derivative of, and the expression that we choose for dv dx is what we will integrate. The way you choose your u is you use this acronym, LIATE, or LIATE. And this tells us the order in which we should set u as. So let's take, for example, our function x times cosine 3x. Our function consists of an algebra portion, which is this x part, and it consists of a trigonometry portion, which is this part. Now, according to the acronym LIATE, algebra gets more priority than trigonometric functions do. So we'll set u equal to x, and we'll set dv dx equal to cosine 3x. So we'll take the derivative of x with respect to x, and we'll find the integral of cosine 3x. The derivative of x is simply 1, so we have du is equal to 1 dx, and we don't need to further solve for dx here because dx is equal to du. Over here, we have to find the integral of cosine 3x. To do that, we'll do a u substitution where I have u is equal to 3x. I take the derivative, du is equal to 3 dx, and dx is equal to du over 3. After doing this, we end up with cosine u du over 3, pulling out the 1 over 3. 1 over 3 times the integral of cosine u du. The integral of cosine is sine, so our final answer is 1 over 3 sine 3x plus c. This expression right here is equal to v. So I'll substitute this along with u into my formula, and since I'm running out of room, I'll do my work underneath, where I have u, which is equal to x, times v, which is 1 over 3 sine 3x, minus the integral of v, which is, again, this expression, the integral of 1 over 3 sine 3x, and of course, we have to include du, which was equal to dx. Now, let's simplify this side. We end up with x times sine 3x over 3. Here I can pull out this 1 over 3 and the integral of sine 3x. For this, we have to do yet another u substitution. That's our third one so far. U is equal to 3x. Now I'll take the derivative with respect to x. Du over dx is equal to 3. Therefore, dx is equal to du over 3. The integral of sine u is equal to negative cosine u plus c. Just keep that in mind for the next step. So I'll rewrite this part, x times sine 3x over 3 minus a third. And remember, I'll replace this dx with du over 3, which I can then pull out as a third. So we have 1/3 times 1/3, and the integral of this is negative cosine u, which I'll replace back with 3x. This negative and this negative will multiply together, giving us a positive outcome, where we have x times sine 3x over 3 plus 1 over 9 cosine 3x plus c. That right there, this expression, represents the integral of question number 1. If you want to find out the answers to questions 2 and 3, make sure you watch the next part of this lesson. We'll see you soon.